I think we should get started. Good morning, everybody. Good morning, good afternoon. On behalf of the HFE Center, I would like to welcome you to the first session of our special seminar series, Why Behavioral Interventions Work or Don't Work. My name is Theo Sandvoort and I'm the director of the HFE Center, the development core of the HFE Center. And this seminar series is organized in collaboration with the program Science of Behavior Change here at the School of Medicine. We are very pleased to see the overwhelming interest in this seminar series. Although not everybody is here, over 800 people have registered for this seminar series, so we're really very pleased to see the interest. It's my pleasure to introduce you to my colleague Brian Kuttner, who will tell a little bit about the seminar series and who will introduce today's speakers to you. I look forward to the presentations and hope that your time spent here will be meaningful. Thank you so much. Brian.
Thank you, Theo. I'm very happy to introduce our seminar leaders today. This particular group of researchers has been involved in developing a set of tools for understanding, planning, and evaluating behavior change interventions. And these tools have strongly influenced my own thinking as an HIV researcher about the intervention functions, techniques, and mechanisms of action in human behavior change. We organized this seminar to introduce you to what they have developed because these tools have rarely been applied in the context of HIV. There's an opportunity here, therefore, to disseminate and implement new tools for your own research, and that is our goal. The next seminar will help you to conceptualize your own study design to understand behavior change mechanisms of action, and then the final seminar will be a chance to discuss HIV studies that have tested behavior change mechanisms. So I'm going to briefly introduce our seminar leaders for today. Dr. Robert West is Professor Emeritus of Health Psychology at University College London, and researches motivation and behavior change, including addictions, especially tobacco use, and is the editor-in-chief of the journal Addiction. Dr. Susan Michie is Professor of Health Psychology and the Director of the Center for Behavior Change at University College London. Her research focuses on how to understand behavior change theoretically and how to apply theory to intervention development, evaluation, and implementation. Dr. Mary Johnston is Professor Emeritus of Health Psychology at University of Aberdeen. Dr. Johnston conducts research on behavior change in health and healthcare contexts and on theory, measurement, and intervention related to disability. And Dr. Janna Hastings is Assistant Professor of Medical Knowledge and Decision Support at University of Zurich and University of St. Gallen, Switzerland. Dr. Hastings' research aims to accelerate translation and integration of evidence into healthcare clinics and to ensure that technological progress is aligned with the needs of clinicians. You are very welcome to ask questions. We're going to have ample time at the end of their presentations to address those questions. We ask that you place your questions in the questions and answers feature so that we can address them later. And with that, I will turn it over to Dr. West.
I think I'm going to start, Brian, if that's all right.
Oh, great.
Good. So I hope I can share my screen successfully here. Good. Can you see that all right?
No, Susan, we're not seeing anything.
Oh dear. Okay. Is that better?
Yep, great.
Oh, wonderful. Good. Hello, everybody. I've been asked to talk to the Human Behavior Change project, but specifically for this seminar on the ontology of mechanisms of action. I'm delighted to be with you here, so thank you very much for including me and my colleagues in the seminar series. We're a large team. It's a collaboration between behavioral social information scientists and computer scientists. But here I'm just given the names of the behavioral social information science team and funded by the Wellcome Trust in the UK. Okay, so there are many challenges in understanding why interventions work or don't, and here are some of them. The quantity and complexity of data challenges our ability to find, extract, and use data. And we have doubling of global scientific output roughly every 9 years, so faster than human beings can keep up with. Secondly, as we all painfully know, studies and evidence syntheses are often underpowered to investigate interactions and mechanisms. Thirdly, we have diverse vocabularies, both within and across domains and disciplines, which really holds us back. And finally, we have a proliferation of theory, constructs, and measures. So the vision of this project, to be going about 5 years, is to develop an understanding of human behaviour to answer variants of what we've called the big question. And the big question is this: when it comes to behaviour change interventions, what works compared with what, for what behaviours, how well, for how long, with whom, in what setting, and why? Now, nobody asks that whole question, but whether you're a policymaker, a practitioner, a planner, a researcher, you're asking a variant, a subset of this question. For today, we're only going to focus on the why, the mechanism part. So to make progress, we need concepts and terms for representing those concepts that are clear and consistent, and that can be communicated across disciplines and domains. So we can really build our evidence in a collaborative way. It also needs to be used by both humans and computers so that we can organise and synthesise large amounts of complex evidence at scale and rapidly, but also make inferences from that evidence to generate new understanding. So this is what we're trying to do in this project. And one of the backbones of the project are ontologies. For those of you who haven't come across these, an ontology is a formal system for representing the world. And on the right here is a very simple ontology, which is 3 entities and the relationships between them. So they consist of uniquely, precisely defined entities and properties consisting of relations with other entities. So it doesn't really matter what you call things, so long as you define them and you can show how they're related to other entities. These ontologies are used extensively in broad areas of science, in engineering and commerce to structure knowledge, and they're systems that form a basis for powerful searching and inference. So going from what we do know to what we don't know. I don't know how many of you have come across this excellent report by the Science, Engineering and Medicine National Academy in the United States. But it's really reviewed in detail ontologies in the behavioural sciences, and with a view to accelerating research and the spread of knowledge. And absolutely delighted to see this report come out and advocating ontologies in our work. Okay, so the problem we're facing in our project on the left is messy evidence growing faster than humans can keep up with. On the right is where we want to get to, turning this into well-organized, useful scientific insights. So up-to-date estimates of the effectiveness of behavior change interventions, unpacking reasons for heterogeneity in intervention effectiveness, and generating new testable hypotheses about behavior change. And we're doing this by an ontology of behavior change interventions, developing that, huge undertaking, and using this ontology to guide artificial intelligence, natural language processing, and machine learning algorithms. So here's the upper level of the behavior change intervention ontology. Bottom left-hand corner, you can see the intervention, the content, which are the behavior change techniques, which we won't be talking about today, and different aspects of delivery mechanisms. We then have on the right-hand side, the outcome behavior and the mechanisms of action that we're talking about today. And as you can see, these are modified by engagement with interventions and the context, and all of those need to be taken into account together to understand its relationship with the outcome behavior. So this is a very top level schematic, and here's another top level, but written in a more ontological format. So you can see that the arrows here have definitions of what the relationships are between them. And there on the left-hand side, you'll see the mechanisms of action. And we have 45 entities, but sitting under every single one of these is a many-layered, many-itemed ontology. And we're calling this the BCI scenario. You can think of it as a condition in a randomized control trial. In order to understand it and extract the meaning from it, we also need to have the details of the comparison, the evaluation study. Not time to go into this today, but just to show you this is the framework. So the ontologies making up the BCIO, we've already published these. These are all on Welcome Open Research. It's an open access platform, and the URL is there. And before the end of this year, you'll see a long list of ontologies, and you'll see number 8 there is the mechanisms of action. And actually, yes, just yesterday, I commented on the draft of the paper that will hopefully be published in the next month or so. So how did we develop the ontology? Step 1 at the top, we identified classes from 83 theories of behavior and behavior change. This was a multidisciplinary review I led many years ago with quite strict definitions of what a theory is and what behavior is. So that was our starting point. We also reused classes from other ontologies where they existed. And this is very good practice. You build on what other people have done and extend what other people have done. We organized them into a coherent structure, then looked to see whether we could apply it to coding or annotating mechanisms of action in the literature. We then had the ontology reviewed by international behavioral science experts and ontologists, and then tested whether they could be reliably applied to code them. So what we ended up with was 261 classes on 7 hierarchical levels. What do we mean by a class? Here are some of them: belief, learning, behavioral opportunity, personal capability, interpersonal behavior, emotion process, any of the mechanisms through which an intervention may have its effect. Everything we do is on Open Science Framework. So that's the URL there. So here, if you look at the back box there, you'll see that we've just enlarged a small amount to just show you the bit about belief, but you can see it goes right from the right-hand screen right over to the left-hand screen. And then the final tool, Janna will mention some tools that are available to search this. But there you see the belief, and then below it are some subclasses of more specific types of belief. You can see that below those that you can't see on the screen, there are other even more specific ones, and then various relationships. So the mechanism of action ontology we developed serves as a framework that can be refined over time. Ontologies don't stand still, so there's ways in which these could be added to, elaborated, etc. It can be used to guide intervention developers when selecting and defining mechanisms in interventions. It can be used to refine behavioral theories, and there's a whole other piece of work that maybe Robert will just touch on, where we've used an ontological approach to specify those 83 theories I mentioned. And there's 2 papers published. The second one is you'll find on Welcome Open Research also. Provides a shared language to communicate about mechanisms in interventions across domains and disciplines. I can't stress enough how important I think this is if we're really to try and accelerate the science and what we can produce with our science, and then synthesize evidence about mechanisms. As I said, everything's open access. So our publications, as I said, are on Welcome Open Research. We also have tools that can be used to browse. So what we call BCI vocabulary, and also an ontology lookup service. And also the ontology itself is downloadable from GitHub. So thank you very much. And I shall now stop sharing and hand over to Robert.
Yes, thanks, Susan. Hi, everyone. So I'm going to give you a very, very brief introduction to a thing called the behavior change wheel, which I guess some of you may be familiar with, and then talk a little bit about how it relates to the ontology. So I'm just going to share my screen. I hope you can all see that. Nod, Susan, if you can see it. Good, lovely. Okay, so what is the behavior change wheel? I'm going to cover what it is, how it helps in the development of behavior change interventions. And as I mentioned earlier, I'm going to talk a little bit about how it links up with what Susan's just been talking about, the behavior change intervention ontology. So the behavior change wheel is a framework for developing and describing behavior change interventions in a way that is aimed to make best use of theories and evidence. And as you'll see in a minute, it forms the heart of a step-by-step guide, which we also kind of call the Behavior Change Wheel Guide to intervention, development and evaluation. And the Behavior Change Wheel was developed and actually the first article on it was published in 2011, and it was based on a comprehensive review of existing behavior change frameworks, of which at that time there were 19, and some of them will be familiar to you. Those of you, if there is any from the UK, you'll remember a thing called Mindspace, which is actually still being used. And there's also intervention mapping. There's a number of these. And what we sought to do is to bring them all together, evaluate them, and construct a framework that would build on their best features. And the original article is down here, and I believe these slides will be available. So if you don't have that, then it's easy to access, or you could just Google Behavior Change Wheel. The Behavior Change Wheel Guide is published as a book, and you can access it there, but I'll come back to that right at the end. Okay, so what is the behavior change wheel? Well, the wheel part of it looks like this, and at its heart is a thing called the COMBI model, or capability, opportunity, motivation model, which is based on a very simple premise, which is that in order for any behavior to occur at any moment in time, whoever's doing the behavior must be able to do it. They must have the capability to do it, psychological and physical capability. They must have the opportunity to do it, the physical opportunity and the social opportunity, and they must be more motivated. This is crucial, it's a slight difference between capability and opportunity and motivation. They must be more motivated to do that behavior than any other behavior that may be on the table at that time. And motivation is divided up into what we're calling reflective motivation, which is our conscious beliefs about what we should do, our plans, our decisions, and so on, and automatic motivation, which is our desires, our habits, instincts, emotions, and so on. And so the capability, opportunity, motivation behavior model sits at the heart of this. Around this maps on then to intervention types. And we think we've identified, and over the 11 years since we did the model, we haven't identified any others, but identified 9 key broad intervention types that you can use to change behavior. And most behavior change interventions will involve a combination of these. And then for authorities, such as governments or health agencies, for example, you would implement those intervention types using a number of different policy options. Could be legislation, service provision, regulation, communications and marketing, and so on. So the behavior change wheel itself, this little model here, then actually contributes to the larger process of developing behavior change interventions. And in that process, before you get to the behavior change wheel part of it, you've actually got to decide on the target behavior and target group. So that's incredibly important to get that right. You then develop the behavior change intervention for that target behavior or those behaviors and those groups. Then you have to build it. And this is where you come to, so all you've got here as a result of this is a kind of broad strategy. You then have to build the intervention using a specific behavior change techniques delivered in a particular way. And then, of course, in our world, we have to implement, disseminate, and evaluate it. And the decisions that we make here are, we make using a thing called the APPEASE criteria, which I won't go into, but essentially the APPEASE stands for acceptability to key stakeholders, practicability, effectiveness, affordability, spillover effects, and equity. So the 5 components then of the behavior change wheel are the COMBI model that I've talked about, the broad intervention types that I've talked about, and the policy options. And then in addition to that, we have ways of mapping the COMBI targets, the things that we think we need to change in order to get behavior to change, to the intervention types, and then we can map the intervention types onto the policy options. And that's a map that, these are things that you can identify through search of the literature, through primary research, or if information is actually not available, then through your best expert judgment. So then, just to see how this works, if you're looking, for example, at identifying COM-B targets, that's targets within capability, opportunity, and motivation that you think could be important in changing the behavior. What I've got here, and I'm not going to go through them all, obviously, because of time, but I believe these slides will be available. And this is quite a useful aid memoir for you when you're developing any behavior change intervention. In terms of capability, just to give you a couple of examples, first thing, they've got to know about the behavior. They've got to think, well, they've got to realize there is something to do. If they don't know about it, then it's unlikely that they're going to be doing it. And they need to know precisely what constitutes it. They've got to know how to do it. They've got to understand, or they don't have to, but in some cases, they would need to understand the benefits of doing it, the costs of not doing it, and so on. When it comes to opportunity, this is the environment in which your target audience is located. This is a social and physical environment. Very important, obviously, in the social environment is norms. And the question is, how far is it considered normal within that social environment? And that's a huge area, obviously, in itself. But you've also got other things like, do they have the time to do it? Do they have the resources or equipment to do it? Are there prompts, cues, and reminders, and so on? And then when it comes to motivation, the questions we want to ask are things like, how worthwhile do they think it is? How much enjoyment or satisfaction do they expect to it? For example, do they expect it to meet a need? How does it fit with their self-identity? So you've got here a sort of list of things that you could turn into more specific questions in your particular domain to identify a particular COM-B target. Then when it comes to intervention types, I mentioned actually there's 9 of these. I won't go into the details again because of time, but it's all on this slide. So you've got education, persuasion, incentivization, coercion, which actually just involves introducing a cost or adding to the cost or expected negative outcome to a behavior. Or if you want to get someone to do something by coercion, then you have some sort of negative outcome for not doing the behavior. Training, restrictions, creating boundaries around the behavior through rules, environmental restructuring, modeling, and what we've called enablement, which is providing psychological, social, and physical resources and treatments to support the behavior. And then the other mapping task is between the intervention types and the policy options, of which there are 7, which I've listed here. Things like guidelines, communications and marketing, legislation, regulations, and so on. So how does this all integrate with the behavior change intervention ontology? Well, this is a framework, and within that framework, then each of those things I've talked about will have a definition, and what we're doing is we're building those definitions and class labels and relationships so that they link up with the ontology. So, for example, the COM-B model obviously links, well, obviously to me anyway, links to the mechanisms of action ontology, while the intervention types and policy options link to the intervention content, behavior change technique ontologies, and the delivery ontologies. And so really, to sum up, what the behavior change wheel gives you is an overarching framework to develop a strategy for developing your intervention, and then a step-by-step guide which will take you all the way from your initial concept through to the final finished intervention, which includes all those other things I talked about, like behavior change techniques and so on. But it also provides a set of formally defined constructs which will become part of the behavior change intervention ontology, so that you can characterize existing interventions when you're doing evidence synthesis and so on to evaluate whether or not they're effective. And I'll just end on this slide, which is the behaviourchangewheel.com website, which gives you more information. And there's also the book that you can get if you haven't already got it. And I shall stop there. Who's next? Mary.
Hi, can you see my screen?
Yep, looks great.
Good. Hello, everyone. Can I start by saying how I really like the title of this webinar series, Why Behavioural Interventions Work or Don't Work, because it's just as important to understand why they don't work as why they do work. And I'm going to be talking about a system that we've developed for linking behaviour change techniques to their mechanisms of action, which allows you to think about how they might work or not work. And I'm going to start with this example, which is an advert issued by the UK Department of Health in the 1980s, when AIDS was just beginning to be something that people worried about. And this was meant to be an intervention that would enable people to change what they did. But it's worth thinking, why might this not work? Well, for a start, no behaviour is specified. And secondly, they seem to be targeting ignorance, but is this message likely to reduce ignorance? When we're talking about linking theory with behaviour change interventions, on the one hand, we have the behaviour on the right, which is anything a person does in response to internal or external events. And on the left, we've got the content of our behaviour change intervention, the behaviour change techniques, the potentially active ingredients within an intervention designed to change behaviour. And in the middle, what do we have? We have the mechanisms of action, the processes through which the BCT affects behaviour. So, for example, if the behaviour is adherence to PrEP medication, then the mechanism of action might be knowledge, that people know about it. And the behaviour change techniques might be giving people information about the consequences of using PrEP medication, or the information about consequences about not using PrEP medication. Some long time ago, we developed a taxonomy of behaviour change techniques. That's 93 behaviour change techniques organised in 16 clusters based on a series of consensus and literature search studies. And this is the original paper if you want to find out about the development of the behaviour change techniques. But just to illustrate what it looks like, this is what it looks like on the taxonomy app. So on the first screen, we see this illustrates 8 of the 16 groupings. So the first screen shows the groupings. The second screen takes the first grouping and shows you a list of the BCTs within that particular grouping of goals and planning. And the third screen shows you the definition, example, and notes for the particular BCT that's been identified. And on this screen, you also get examples and notes. So it gives you quite a lot of information about the BCTs. So that's how that's the set of BCTs we took in to develop the links to the mechanisms of action. Now, for the mechanisms of action, we've identified 26 for this particular piece of work. So we started off with 14 mechanisms of action from the theoretical domains framework. And on the right, you can see the papers that developed that. So each of these mechanisms was developed by consensus procedures and validated in further consensus approaches. And you can see that there are 14 different groups of theoretical domains. We added to that frequently occurring clusters of mechanisms of actions. So these are from 83 theories. What were the commonly occurring clusters of mechanisms of actions? So that's where we get to more social mechanisms of action, such as subjective norm and social learning. So the task that we set ourselves was to link BCTs and MOAs. Which BCTs did we think would be likely to change which MOAs, and developed it into what we call the Theory and Techniques tool, which is a free online platform that links behaviour change techniques, the BCTs, with their mechanisms of action, the processes by which the BCTs bring about change. And that's available as part of the Human Behaviour Change project at this particular website. The team involved in doing this was led by Susan Michie and involved Marijn de Bruin, Alex Rossman, Mike Kelly, Rachel Carey, Lauren Connell, Hilary Groark, and Derek Johnston, and was funded by the Medical Research Council of the UK. We did 3 studies. The first was a literature synthesis, where we looked at published interventions, and we did a systematic review of published interventions in which we extracted all of the links that authors had made between behavior change techniques and theoretical constructs, mechanisms of action. And we set a criterion that any link that was occurring beyond chance expectations, we called a link. In the second study, we took the 26 mechanisms of action and a large number of behavior change techniques and had experts say, which of these BCTs do you think would shift each of the mechanisms of action? And in addition, we asked them which of these BCTs would not influence that mechanism of action. So it allows us to make non-links as well as links. And then in the final study, we brought the 2 studies together. We looked for where there was agreement, and where there wasn't agreement, we looked for reconciliation with a new consensus study with a new set of experts. And that allowed us to say that these look like links, these look like not links. There are some where the evidence is a bit ambiguous, and there's some where the evidence is just inconclusive. This is what the Therian Techniques tool looks like. This is the home screen. On the left, you have the BCTs, and you can see goal setting behavior, and you're getting the first group, but it goes right down the whole 93. Along the top are the mechanisms of action. They all have abbreviations, but if you hover over them, if you hover over this one, it tells you it's knowledge. If you hover over this one, it tells you it's skills. Each cell has a conclusion. It tells you whether this is a link, i.e. that this BCT is likely to change that mechanism of action. A non-link, this BCT is unlikely to change this mechanism of action. The evidence is inconclusive, or there's a lack of evidence. And when you click on a particular cell, it gives you all of the evidence from our studies pertaining to that specific cell. If you want to use TAT to design an intervention, what you need to know is what's the behavior that you want to change, what's the mechanism of action that could be changed to change that behavior, and what BCTs might change that mechanism of action. So for example, if the behavior is the use of condoms for safer sex, and you think the mechanism of action that's relevant for this particular target group of people is knowledge, then the TAT technique would tell you that information about health consequences is appropriate and might work. But it also tells you that BCTs involving prompts and goal setting are unlikely to work. But remember, the TAT technique is only telling you what we believe will work. We don't actually have the evidence that this technique will change this mechanism of action. So it's a guide. But equally, if we use the same behavior, but now have a different mechanism of action, social influences, the BCT gives you a different set of links. So if you believe that if social influence is your mechanism of action, then information about other people's approval and social support are likely to be useful in changing that behavior, whereas goal setting and behavior practice are not. So these get a green square, these get a blue square. TAT can be used, as I've suggested, to design an intervention, as I've illustrated, and bearing in mind that the limits of our empirical evidence. Secondly, it can be used to understand how an intervention changes behavior. You have an intervention that works, you want to know why it works. Or you have an intervention that doesn't work, and it allows you to think about why it might not work. It also allows you to make links to theory. So we're working at the level of mechanisms of action. These mechanisms of action are constructs within theories. And if you want to link to theories, you are looking for theories that involve those mechanisms of action and what the other mechanisms of action might be within that particular theory. The TAT can be found at that address or on your mobile phone or as part of the Human Behaviour Change project. And I'll just end it there. Thank you very much for your attention.
Great. So I think I'm up next, and I'll just share my screen. Hope this works. Let's see if I put this and that. Did that work? Great. So thank you very much to the organizers and to the other speakers for giving me the opportunity to speak. I will talk about the technical side of the Human Behavior Change project and the objectives to automate a bit more using the Human Behavior Change sort of structured knowledge base in order to automate the evidence synthesis problem. So the problem, as was mentioned earlier by Susan, is that the evidence grows at a pace faster than it can be consumed. And even the process of generating synthesized evidence itself is slow. And by the time you finish sort of conducting a systematic review, the findings may be out of date. So this is really frustrating. I love this picture, which was accompanying this Nature article on living systematic reviews, or the need for living systematic reviews, which depicts this kind of running away mountain of papers and various policy makers and intervention designers trying to catch bits and pieces of this running away paper monster. And you can see this in every field. I think it's not specific to behavior change, but it is also the case for behavior change that the number of findings and studies is growing exponentially. So the Human Behavior Change project wants to change or take a different approach to solving this problem by using automation to structure the evidence and then to combine automatically the evidence. So this depends on several components. One of the components, which was already mentioned, was the development of the ontology. The ontology itself enables evidence to be combined by providing kind of standard, I was distracted by the chat for a second. So the ontology provides kind of standard ways to describe your intervention components, intervention mechanisms of action. This is just one part of the problem. If you have standard descriptions, you can, of course, then combine the findings much more easily. But the other part of the component is the fact that you need then to apply those standard descriptions to the literature. It would be great if this could be done prospectively for studies sort of being written using those terminologies and attributes in advance. But failing that, when we look at the sort of existing literature and we try and synthesize that, then we need to associate our standard categories or ontology classes with the existing literature. So you can see here an example from the mode of delivery part of the ontology, where you're talking about aspects of the delivery, such as whether the delivery was face-to-face, whether it involved a digital application. So the process of associating ontology terms with literature is called making annotations, and the annotation of the literature becomes the kind of structured knowledge base which we then afterwards can synthesize. And the objective of the Human Behavior Change project was twofold. On the one hand, to show a proof of principle of the technology and work it out all the way through for a use case in which annotations were made by hand by the researchers associated, but also to explore the possibilities for these type of annotations to be made automatically in the future. So annotations of ontology terms to the sort of literature findings can have different types. You can have presence or absence. So when you're talking about an intervention, then a particular component or a behavior change technique may be present or absent in the intervention which is being reported. They can be associations between a particular ontology type and a value or a string which is reported. So for example, the country as a setting, the ontology term is country, but then you have various values like the United Kingdom or the United States or other countries. Or they can have some numeric value associated with them. So for example, you might be annotating the mean age of your population of your intervention, and then the ontology category will be mean age, but there will also be, in addition, some number which goes into the knowledge base, which is the actual mean age, which was reported in the literature. So then you have, as I mentioned, a kind of knowledge base of the structured information from various multiple studies. And what we did is perform this kind of manual annotation to create a gold standard in order to show the value of this approach, using the behavior change intervention ontology consisting at the time of last computing of 734 different classes. This is various different, this is structured over various different parts. I think the mechanisms of action is somewhere around 250 classes out of those 7. So it's a really big component, a really big part of the overall ontology. And then the focus of the first scenario was on smoking cessation, for which 455 papers were annotated. Actually, a few more were annotated, but then in quality control, we had to remove some of them. And over those 455 papers, we had 1,098 intervention arms. So each arm represents a behavior change intervention scenario, complete with various aspects such as population, setting, intervention, and outcome. So then in the future, various components would aim to automate the process of adding information to this knowledge base, but I'm not going to talk further about those components today. What I'm going to talk about is the objective of synthesizing the information across a whole body of annotated research in order to predict outcomes in hypothetical scenarios or in extrapolated scenarios across the whole of the evidence base, but really importantly, predicting outcomes with explanations. So our objective is not just to provide a synthesis of the evidence in the sense of a usual kind of evidence, let's say, analysis that you might report in a systematic review, but rather to provide a usable tool which can be used to explore the evidence base more interactively, and thereby to help guide the development, evidence-based development of future interventions. So taking our ontology structured knowledge base of annotations of the literature, we then want to plug in a component which predicts outcomes and gives explanations based on the literature for the outcomes that are predicted. And just to note that, so what you see here on the right-hand side is an example of outcome predictions in this annotated data set based on a linear regression model. And what you see around each point, so we have here the actual outcome value in the study compared to the predicted outcome value. And what you see here is that there is a lot of noise or unexplained variance in the data set. So prediction of outcomes is not an easy task and not an exact task. And the evidence is having some inconsistencies in it based on various variables and potentially under-described in some cases. So again, our objective is to sort of connect up the prediction with the explanation and make this variability explicit, not to sort of solve all the problems. Although in the future, we hope all the problems in the evidence will be solved. This is not where we're at right now. So we wanted to design a computational system based on machine learning, which would be able to make this type of prediction, but at the same time give explanations. Now, systems which are based on what's called rules are considered by most computer scientists to be the most explainable, or the kind of systems which lead the most natural explanations, because humans tend to think in terms of rules for sort of causally when they think about their own sort of understanding of, you know, if this, then that. So if you do the intervention in a healthcare setting, then the intervention will be more effective and so on. But systems so the advantages of rule-based systems are that they are naturally interpretable. You can induce rules from data, and this is what we're trying to do. We're trying to induce a kind of a rule knowledge base from an evidence data set. And you have, within the rules framework, you have a kind of easy integration with the logical structures that are specified in your model of how interventions work, and this is given by the ontology. But so rules seem like a natural or a good selection for the type of technology to use here. But normal sort of traditional expert systems based on rules, or systems that learn rules from data, have various shortcomings which we tried to overcome. So one shortcoming is that when you have a large data set as we do, your rule system may learn simply many very long and very esoteric rules. And actually, at the end of the day, if you have lots of very specific rules, it's then not so easy for humans to, again, make sense of these combinations of very long, very specific rules. So interpretability requires that the rules be short and to the point. And then you have to somehow convert your continuous numeric features into binary features in order to work in this rule formalism. And finally, it's the rules are not quantitative, so they're not usually trainable using machine learning approaches that are efficient and kind of modern. So what we did, and I won't go into the really technical details here, but what we did is we designed a rule-based model, so a machine learning model, which had weights attached to the features, so the specific variables in each rule, and to the outcome. And then based on these weights attached to the features and to the outcomes, and a combination of rules, we're able to predict an outcome, but also rank the features with regard to their importance for the outcome. So this is a trainable system because the parameters, the weights are all numeric and differentiable. What that means is that you can look at the predicted output and how much it differs from during a training phase, how much it differs from what you need to see, and then change the weights of the model based on how good the model is performing. And as a result, you get quite an efficient predictive system based on modern of our model, which we did based on cross-validation. So that means that you take some part of the data set and keep it aside and train the model on the other part of the data set, and then you check the predictive performance on the part of the data set that the model didn't see during the training phase. So during cross-validation, we compared the performance, the predictive performance of our model to various other models. So for example, we compared it to a standard architecture deep neural network, which had several layers. This is sort of state of the art for application to learning problems in most fields at the moment. We compared it as well to a natural language-based model that had been developed previously by the, in the context of the Human Behavior Change project to attempt to solve the same problem. And we compared it to a linear regression model, which doesn't have maybe as much nuance. And finally, to a sort of standard interpretable model, which is decision trees, which is quite similar to rules-based models. And what we found is that our model performs, as you can see here, the green box is fairly close to the blue box. So it performs comparably, fairly close to, or almost the same as a sort of completely uninterpretable deep neural network model. So this was a really, really good finding because our model is transparent and you can see explanations for all of the predictions that it makes. And it outperforms the other two approaches, and in fact, dramatically outperforms the other interpretable approach that we compared it to. So this was really good, and we think this is a really promising model going forward, but we still have a fair bit of work to do. So what this looks like at the moment is that for each prediction, you get several rules that were used in the prediction as the kind of output of the model. These are ranked by how important or how relevant they were in the prediction. And you see, for example, you can have rules for specific variables, such as that problem solving was used in the intervention, and that when problem solving was used, this is predicted to raise or improve the outcome. In this case, outcomes are given in percentages on smoking cessation, so percentage of your population. So here you're talking problem solving having a positive effect, increasing the rate of smoking cessation. Or you can see interaction. So for example, if you're talking about an adult and then a doctor is giving a pill, this would have a strongly positive, this combination would have a strongly positive effect on the outcome. On the other hand, if you're doing biochemical verification as opposed to, for example, self-reported smoking cessation, you may see a reduced outcome or a reduced rate of cessation, and that makes sense. We were also able to show that by using the semantics attached to the ontology, and I won't go into details of how we do this, but this is really, really important. By using this sort of model of behavior change that is represented in the ontology as part of this training system, we were able to reduce the length of the rules, and that the rules that then were learned were more significant and more relevant to the users. So we think this is really exciting. What we are working on now is improving a sort of accessible web interface and doing a study with real users. So all of this consists of, as Susan mentioned, a kind of resource which we hope to put out and make useful for the community. This has been built in collaboration with various partners and various other partners, which we are now starting to collaborate with to sort of extend the reach of these resources further. Everything we've done is open source. It's all available if you want to reuse it. It's all open data, and there are tools. Susan mentioned tools before, I think, but I just put here some URIs again for a search tool and a visualization tool. And we've been working extensively to kind of build a community around this type of approach, because the more that these frameworks are used, the greater the benefit for everybody who uses them. And one part of this that we've been working on is what we're calling a behavioral and social science ontology foundry. And this I have as my final slide, a QR code which takes you to the page to sign up for the mailing list attached to this ontology foundry. And through this effort, we hope to build a community of practice around the use of ontologies in the behavioral and social sciences. And it also links to the visualization tools, so other participating ontologies can also benefit from these tools. Thank you. With that, I stop, and I'll stop sharing, but yes.
Thank you. This has been terrific. There's so much stimulating content, and we are lucky enough to have about 30 minutes in which we can address some of the questions that have come up. I think we'll start with Michael's question. And I'll just summarize this as kind of, where do you start with all of these amazing tools that you've developed? Where do you start with your project? And Michael asks, how do you suggest using the behavior change wheel and mechanisms of action framework, as these are very broad terms? Should behavioral theories be used to explore further and really understand the specific mechanisms of action, for example, social influences? And how could you determine which theory would be useful regarding which actual psychosocial constructs might be relevant and how they could be changed?
Yeah, good question. Susan, shall I start and then you can add? So, the capability, opportunity, motivation model and the behavior change wheel framework are broad models and overarching models, and they provide a sort of framework within which you should, if we've done our job well, be able to see where those more specific models that apply in specific domains fit in. And so these broad models aren't a substitute for that. They're a way of sort of ensuring that you can try and see where all these different models fit in. And that's I think, where we get to the answer to the last part of that question, which is, how do you choose, what model to use? And the way it's done at the moment, as I'm sure many of the people on this call will be familiar, is kind of like the model that you're most familiar with, or your favorite, or the one that you learnt about. And obviously that's not very scientific, and it's not the ideal way of doing it. But if you can use this broad model, or combine the capability, opportunity, motivation model, to say, well, okay, let's think about it very broadly. What knowledge, what skills, what parts of our environment, what motivations from our analysis of the literature or our primary research that we've done looks like being our best bet for having to making a change. You can then drill down and say, okay, well, what models are there? What theories are there that specifically focus on that, on self-efficacy, for example, if that turns out to be a thing that you think is going to be important, or about changing norms, or all of those things, if you're adherent to self-determination theory, there may be things around connectedness and competence and so on. So it provides you with an overarching way of then drilling down and saying, okay, specifically, and that's then where you connect with the mechanisms of action and behavior change technique tools to say, well, okay, that tells me what mechanisms of action I'm going to be interested in, and then you can use the tool to sort of say, well, what have other experts in the field thought would be good ways of influencing that particular mechanism of action. So you do have a sort of a guide, an usher to show you to your seat on this particular thing. But you start by getting into the cinema, and then you sort of get the usher with the torch, and it can show you. But there's no guarantees, obviously. Human behavior is incredibly complicated, and which is why whenever you're building an intervention, you have to do it very iteratively and with pilot testing, et cetera, et cetera.
I would like to come in here because I think there's something else that is being asked about here, which is how we link to the actual series. And the way we've been talking so far, we've been talking about one mechanism of action at a time. If you follow what Robert's suggesting, and your mechanism of action guides you to a theory, so you've got the idea of self-efficacy. But if you're going to work within Bandura's theory, he would say that shouldn't work without outcome expectancies. So you want to operate those two mechanisms of action together, because self-efficacy without being able to do it without wanting to do it in Bandura's terms shouldn't work. So you need to work on outcome expectancies as well as self-efficacies, so that what we don't do is go from the mechanisms of action up to the theory, which shows you what the other mechanisms of action are that works with that one.
Actually, I should say, Susan did ask me to say about it. I sort of ran out of time, but we have a way of using the sort of ontological approach to create what we've called an ontology-based modeling system, in which we've taken a very large number of behavior change theories. And I can give you the details of the paper. It's published in Nature Human Behavior, I think. For that system, so that you can see exactly how those different components of theories link up together to generate the outcomes that those theories propose in combinations.
Maybe if I could just add a couple of thoughts to what's already been said. When we did the review of theories of behavior change, one of the things we noticed was how the same things were being described with different terms, and the same term was being used to describe different things. And I just thought to myself, how are we going to make progress, as a discipline, if this is happening? And that's why when I learned about ontologies and then being able to specify things more precisely in a way that everybody can understand, everybody can share that terminology, we then thought, well, let's specify those 83 theories ontologically, with precise definitions. The other thing was that if you looked at them, and there is a book called, I think it's called Theories of Behavior Change, I don't know, but you can find it or email me afterwards. If you look at that, we represented as much as we could the pictures that theory authors had drawn, and usually they're arrows, but nothing about what those arrows meant. And incredible vagueness and things missing, etc. So what we did is we represented that as ontologies, precisely defined entities and precisely defined relationships with those entities, sent them back to the authors for them to comment, because we didn't want to misrepresent their understanding of the theory. So that was a very interesting process. And then we've published all of that now. And the next stage, which Janna is going to head up at some point towards the end of the year, I think, try and put all of these together, because the other thing is only 2 or 3 out of those 83 theories were comprehensive. Most of them were partial. So my kind of idea is that we'll look to see what are the constructs or the entities and the relationships that feature time and time again. Because if different theorists at different times in different countries working different domains come up with the same thing, then that is really big. And I hope what will come out of that is maybe 2 or 3 sort of theories that really summarize what people have been saying. Just one other point, I know this isn't directly about what was being asked. But how do we move forward? How do we improve our theories? Often people talk about testing theories, but you can't test a theory as a whole. You can test propositions or tenets or mechanisms of action within theories and build it up like that. And that's where, you know, I think the theory and techniques tool also will help, is if you want to test, you know, a mechanism of action, then how do you do it? You know, what behavior change techniques do you use to try and change it? But I think there's, it's such an important area. We don't really talk about how to advance our theories. We need to do it collaboratively. We need to develop tools where we can work collaboratively together.
Thank you. Let's go to Angela's question, actually Ashley's question at 10:18. How does this ontology structured data being used to predict outcomes take into account racial or structural determinants of health influences on those outcomes? And as a follow-up, if using artificial intelligence or machine learning, how do you ensure the models don't inadvertently promote health inequity for various disadvantaged groups?
So maybe I can start, and then Susan and Robert can jump in. So first of all, we have population attributes as a variable, so it's at least explicit. It's not implicit, but explicit as far as it's mentioned in the papers. And then we are using machine learning, but it's a transparent model. So the problem with bias in machine learning is typically coming from not transparent models. So your machine learning model kind of launders the bias that goes in by obscuring it, right? And then your predictions as a result of the data that was biased that went in are skewed, but there's no link back to the skew. Whereas we have a, let's say, transparent or a glass box model, so you can see which variables were affecting the prediction. And so at least this makes the whole process explicit. Now, unfortunately, there are still gaps and really important shortcomings in the evidence that goes in. And about this, we can highlight the problem, but we did not solve this problem. I don't know if others want to say something.
In terms of the ontology, and as Janna said, the ontology is intended to cover all levels that you might be interested in, from the individual, organization, population, group, and so on, and with connections between those. And that is a very, very important point, which so that's good to raise. In terms of the extent to which the ontology itself embodies a bias or embodies cultural or subcultural sort of perspectives, I think this is a tremendously important point. And of course, we're using the English language. We come from a certain sector within our culture, and we need to be incredibly sensitive to the way that this ontology represents the world. So ontology, the sort of ontologies we're talking about here are what's known as realist ontologies. So they do come from a position that there is a world out there, but that's not to say that those ontologies are the only way of representing that world. They are a way of representing that world from a particular perspective for a particular purpose for scientific discourse. And I think it will be really important for these ontologies to broaden these perspectives, to get to involve the communities that are critically affected by these, using co-production, so that we don't inadvertently find ourselves coming up with classes and class definitions and things that actually are wrong or in some way embody a perspective that is unhelpful or inappropriate.
Using the kind of models that Janna's speaking about, it should also be possible to inquire of the data whether the models are fitting in the same way for the groups that you might think are more likely to benefit from an intervention or who are particularly seeking an intervention, so that you can actually look to see if your intervention is working the same way for a particular group of people who may be having particularly bad outcomes. So you can actually drill down on inequity a little bit more.
And just to say something more about the population ontology, which is incredibly important for this. We looked at all the ontologies and classification systems, both sides of the pond and other parts of the world, to look and see what's the best way of doing this, and got a lot of feedback to refine it. But ontologies are living things. So first of all, we've only gone down to a certain level. We're one research project. Yes, we'd be going 5 years, but even that's a huge amount of work. But also within ontologies, there are synonyms, so that really important that they get linked up with other terminologies and other languages. And in the fullness of time, and I think this is where, getting together within the community of practice that Janna talked about, I hope that people will get funding to develop this sort of approach, being able to incorporate, many other groups and many other perspectives. So these are only tools, they're living tools, and they need to be developed to be maximally useful and to avoid any kind of problems like that.
Thank you. I think this might be, Susan, what you just said might be addressing a little bit of this next question. There are 2 questions from Musrat, and I'm just going to couple them. Is there a distinction between the usefulness of these tools in high-income country contexts and low-income country contexts? I would assume the relevant determinants will be different based on context. And then the follow-up question is, can you provide practical examples of how behavior change model was used and actual behavior change was achieved sustainably at the population level in low-income country settings? I worked in WASH behavior change in low-income contexts for many years, and the consensus now seems that focus should not be on behavior change at all. Instead, focus should be on investments in engineering and infrastructure. There's a reason that diarrhea is naturally not a problem in high-income countries, but it is a problem in low-income countries. High-income countries did not use behavior change to eliminate diarrhea years ago. So does the theory and techniques tool also present examples where no behavior change is not useful at all?
Can I just start with a couple of reflections? First off, one of the motivators for the Human Behaviour Change Project was me sitting up for 8 years on the Public Health Interventions Advisory Committee of the organisation in the UK that makes evidence-based recommendations for our National Health Service and for public health. And not only did it take, 1 to 2 years to do systematic reviews to answer questions for ministers in the government, and by the time we'd got the answers, that minister had gone or the world had moved on or whatever, very slow. But also what I was observing time and time again was most of the literature was in the US, because that's a wealthy country where a lot of the research evidence is generated. And we were trying to apply it to, inner city life in the UK, really different context. And so I also began thinking about where in the world is the greatest need in terms of health. It isn't the United States, it isn't the United Kingdom, it's sub-Saharan Africa, other parts of the world where there's least research, least investment, least evidence that can be drawn on. So part of the motivation for this was to find out what about our evidence is generalizable to very different contexts. So that's one of the things one of the uses I want this to be made. But that is also requiring theorizing about context, which we're not good at, explaining the heterogeneity, what can be generalized from what type of context to what type of context. The other thing I'd just like to say, having just spent 3 days chairing WHO's behavioral science advisory group, that this issue about context and relevance of evidence to context is incredibly important and absolutely at the heart of the work that we're doing there. So we're using frameworks and tools such as the ones we've been talking about, but ensuring that everything is co-created, co-produced with people on the ground, involving many different types of voices and perspectives and lived experience. So tools are there to be used. They're not a solution, and they need to be used in association with the people that their world, where the hope is, the plan is to improve things. So those are two very general reflections. I realize I haven't really directly addressed the questions, but hopefully others can pick up from where I've left off.
On the issue of infrastructure changes, this is incredibly important because there is a tendency to sort of think of behavior change as things that you do to people, counseling, legislation to change their behavior and so on. And then on the other side, infrastructure change as something which we do, which people inhabit, and that then influences their behavior. But what we try and demonstrate in the behavior change wheel, or illustrate in the behavior change wheel, is that these two things are part of the whole system. So, if you take a systems level approach or a system type approach, then all of these things are important. So it's absolutely correct to say that structural changes, building things, providing facilities and so on, can be and often are really important for achieving health outcomes, but almost never are they the only thing. They only work in the context of people interacting with them and behaving with them in ways that then enable them to be effective. For example, vaccination, a really important, obviously, example right now is, vaccinations are fantastic, but if no one takes them up, then you might as well not have them. So infrastructure changes will be really important both in achieving behavior change, but also behaviors are really important in getting the from infrastructure change. And what we try and do in our approach is to show how those two things work together.
Great. Mary, you unmuted, so I'm not sure if you wanted to respond as well.
I think Robert's really made the point I want to make, that if you change the infrastructure, you may have a direct effect, or you may actually change how people behave. So that if you set up a building with the stairs as you come in and the elevators around the corner, people will use the stairs more than if the things are the other way around.
Thank you. There are so many high quality questions, and we're not going to be able to get to all of them. So I'm just doing my best to select the ones we could get to. This next one is from Julie Evans. Could you comment on how we might use your work in relation to implementation research approaches and models, which many of us are using to assess health interventions, such as Smith et al.'s implementation research logic model, the IRLM, that incorporates other models such as Dan Schroeder's Consolidated Framework for Implementation Research, CFIR, to explore the determinants of an intervention, and Proctor's work on implementation outcomes, for example.
Well, I'll start just with a couple of comments. Implementation is all about behavior. It depends on human behavior. So really everything we've been talking about is relevant to implementation and implementation research. Now, in terms of which frameworks you use to guide that, I think it's really down to what people find most useful. I've worked with more than one of them, and some of them I find more or less useful. So I think those are the two things I'd say is, see what your purpose is, what are you trying to achieve, and then which framework is most likely to be helpful. For myself, I do like frameworks where entities are well defined, where they're quite specific and precise, and relationships are well defined. But others find other types of framework helpful to work with.
And sometimes different frameworks are relevant for different kinds of work that you're doing. So that if you've got a big budget to change the behavior of a whole community, you can develop a complete proper intervention. But we've also worked with situations where there's something arises, something's got to be done tomorrow. What kind of framework do you use then? And I think then it's not possible to do the background investigation. And we've been working with a framework that allows you to have a much quicker response to that. For example, if it arose in a clinical situation that a patient said they had a particular issue, or that might arise in an implementation situation where something is not being implemented that should be, and it's urgent that it's implemented immediately, then you may not be able to do the full intervention. And just as an aside, it was implementation research that led us to develop the theoretical domains framework in the first instance. So all of those theoretical domains were domains that applied to understanding why people might not implement evidence where the evidence was good.
This next question is also, I think, related to implementation science, and I think it's just an opportunity to clarify some of these tools. It's from Issa. How can we relate behavior determinants, barriers and facilitators, to the mechanisms of action?
I can make a start, Susan. I just want to make a point in relation to that, and that is that ultimately what you're looking for is a causal model. You're trying to create a model which, at least in your hypotheses, links things that you might do to the changes that might take place. Now, one way of doing that is to look in the at what's going on at the moment and look at, for example, what are called determinants of behavior. But this is a good starting point, but it can lead you astray. And the reason is that all you can tell when you look at existing correlations between so-called determinants and behaviors is what's occurring now. It doesn't tell you what could occur if you change the environment, for example. So it may well be that the best way of changing the behavior is completely outside whatever whatever's going on at the moment. Like, for example, just paying people a lot of money to do something can be, can work, even though that would never show up in a sort of determinants analysis because no one had done a study, looking at the correlation between being paid to do something. So don't be sort of just too narrowly focused on looking at correlations between existing factors and the behaviors. Think about the causal model and ideally use something like COMBI or some broad model to say, well, where should I put my efforts here? But it basically comes down to coming up with a causal model.
There's also something that happens in the language. So the implementation researchers have found it quite useful to talk about barriers and facilitators. But when it comes down to it, you can think about the barriers might be lack of capability. The facilitator might be to increase capability. So that these things are not independent ideas. In a way, the models we're talking about are more precise ways of representing what the barriers and the facilitators might be.
Yeah, I agree with all of that. And I'm just going to add one thing, which is one of my little bugbears, is the word determinant. It's very deterministic. It's assuming linear causality, whereas we all know that understanding behavior and how best to change behavior means one has to think in terms of systems and interactions and complexity. And so I much prefer the word influences on behavior rather than determinants of behavior. But that's just one of the things I'm trying to change about the world.
Here's another question that is an opportunity to clarify these ontologies. This is from an anonymous attendee. I assume that this ontology is focused exclusively on intervention that targets behavior change explicitly, rather than other aspects of human experience, for example, change in experience of symptoms or feelings, for example, emotion dysregulation or distress. Am I right in assuming that for these other cases of intervention, which may lead to behavior change, other ontologies would have to be developed?
Janna, you're in an ideal position to answer that, given your own background in developing ontologies.
Yes, so I think so there are some ontologies which focus more on sort of psychological entities such as emotions. There's an emotion ontology I was involved in the development of. And in general, the scope for each ontology should be clearly defined, and then you gain the most value if the ontologies that are developed can work well together, sort of as a framework. So if each picks out a portion of the overall domain of whatever that we are interested in and works on that within a certain collaborative framework, if then you can use all of these different ontologies together, you end up with sort of cumulative and exponentially growing benefits to the community, sort of from this collective effort to structure the things that we study and our knowledge about those things.
Yeah, so we're making sure that we link the behaviour change intervention ontology to the emotional ontology that Janna referred to. Similarly, Robert's in collaborative project has led the development of an addiction ontology. Again, that will be linked. So the more that these can be linked with other areas of human functioning, the better. And this is why we've set up this repository that Janna mentioned earlier, because at the moment we only have a biomedical repository for ontologies, and we think it's really important to have one for social and behavioural sciences, where we can really begin to bring all those ontologies that we're aware of together in one place, so people can find them and then work to develop, improve, and link them up. Then they'll be more useful to us.
One of the things that we found very early on in doing this was that we needed a much better precise definition of behaviour. So these things can get confused. So you can be looking in the wrong ontology if you think that an emotion is a behaviour. And very early on when we were running workshops, it was very clear that we had to help people to know what we meant by behaviour, and to be clear that we weren't talking about thoughts, we weren't talking about emotions, and that there is a necessity not just for an ontology of behaviour change, but ontologies to deal with these other things like emotions and thoughts.
Although I should say that for the mechanisms of action for behaviour change, emotions and thoughts and perceptions and beliefs and so on were all relevant. So we have explicit links from the behaviour change intervention mechanism of action ontology to all of those different psychological domains.
But they're mechanisms of action to change behaviour.
Yeah.
And it was keeping people on what you're actually trying to change, and the mechanism of action is not your target, it's your means to changing your behaviour.
Yeah.
In looking at the time, unfortunately, we have to bring this to a close. There's several more questions that are really compelling, and I think we could go on and on and on. I want to thank you for joining us, and the audience for joining us, but for the speakers for this incredible seminar. It's a wealth of knowledge that you've shared with us and tools, and we will post this on YouTube so that people can access those tools appropriately. It's really been fabulous. So thank you very much for this. And then I'll just announce that the second session will be on October 4th, and that will be more applied on how to design a mechanistic study for behavior change. And then on November 1st, there'll be session number 3, which will be looking at studies that have actually evaluated mechanisms of change in HIV behavioral research. So thank you so much, Robert, Susan, Robert, Mary, Janna. It's just been fabulous. Thank you so much.
Our pleasure. Thank you.
All right,
Bye.
take care, everyone. The links are in the chat for to register for these other seminars in the future, and I hope everyone has a wonderful day. Take care.
Thank you. Bye.